Hello everybody, I'm Soumya Verma, currently pursuing my fourth year BTech degree in Electronics and Communication from SRM University, AP. So, in this video, I will be talking about the project Washing Machine Simulation, which I have recently done at Emertxe Information Technology. So, firstly, we'll move to our index. What are the steps which I have performed during this project? So, first step is basics of embedded C. Second is introduction to embedded systems. Third is introduction to the PIC16F8778 microcontroller. And fourth is the introduction to tools. MPLab XIDE and PICSimLab. These are the two tools which I have used for this project. And last one is our implementation of the project. So, in the beginning, we have started learning embedded C. So, what is embedded C? It is a free formatted programming language, highly efficient and portable. It saves time and memory resources and can be used for general purpose programming. So, why did we choose embedded C? Because of the following reasons. It is closer to hardware for precise control. It is efficient and lightweight for limited resources and portable across hardware platforms. And it works with assembly if needed. It is easier to read and maintain than assembly. Now, we'll talk about embedded systems. What is embedded system? It is an integrated circuit which is capable of being performed to do a specific task. The design normally has restrictions on its memory size, input-output capabilities, peripheral functions. And how do we choose this microcontroller? We choose them based on the following criteria. We have application performance, price availability, availability of tools, special capabilities. And we have various types of embedded systems, which includes first one is standalone system. So it is a system which take its own decision. Example, Tesla car. It is a self-driven. And second one is real-time systems. So these systems are designed to perform tasks within strict timing constraints. And the correctness of the system depends not only on the logical result but also on the time at which the results are produced. Example is our flight control systems. And third one is network systems. So these systems are connected to a network like LAN, WAN or the internet in order to communicate other devices or systems, and they often function as part of a larger distributed system. Example, we have IoT systems, and last one is our mobile systems. So these are compact, portable, embedded systems designed to support mobility. Examples, we have smartphone, smartwatches, etc. Now we'll move to the components of embedded systems. So it includes a software, a microcontroller, a microprocessor, or system on chip. And we have other components like sensors, ADC, DAC, actuators, memory, FPGA, diagnostic port, human interfaces, and auxiliary system. So how do we provide any input, and how does this microcontroller function them and gives us the output in real-time system? So sensors they measure physical data like temperature or give an analog voltage. And what does this ADC do? It changes that analog to digital form, and then this microcontroller takes this digital data, run the program and decides what to do, and it is forwarded to DAC. DAC is a digital to analog converter. So whatever data we are getting from microcontroller, it converts that to analog and pass to the actuators. So this is the process, like how any operation is being performed by any microcontroller or microprocessor. Now we'll move to microcontroller. So what is microcontroller and what are the things it comprises of? It integrates a CPU, RAM and ROM on a single chip in order to perform control tasks. It also includes timers and input-output ports for interacting with external devices and timing operations. We have several peripherals like ADC, serial interfaces, and PWM, which is built to handle various applications. And its compact design makes it ideal for embedded systems like appliances, automotive systems, and industrial controls. And what is the process which we are going to follow for this project? Firstly, we have a requirement, second, analysis, third, we have a design, and fourth is the development, and last one is our implementation. So, we'll move to our requirements and analysis. Firstly, we'll talk about our purpose. What is our purpose to do this project? So we'll develop a washing machine which is a home appliance in order to wash laundry, and we will be using variety of washing modes in this project. So this is our functional requirement. We are using 12 different program modes. First one is daily, heavy, delicate, whites, stain wash, shari, villains, bedsheet, rinse plus spin, spin only, wash only, and aqua store. And we have 4 different water levels, that is low, medium, high, and very high. And for each level we have given certain time to uh, complete those tasks. This is the analysis of the whole project. So first one is our power on screen, and second is powering on screen, and third one is the various types of program modes we are using in this washing machine project, and fourth one is the water level program screen, and fifth is the start screen or stop screen, um, and this is the continuation. So first one is our screen which displays our function, like we are using function wash, and timing is 37 seconds, and we have two options, like we will when we will press switch 5, then it will start the process, and when we want to pause it, then we can press switch 6. And then we have door status screen, and last one is our screen which displays the program completed, removed logs. And these are our software requirements which we have used in this project. So MPLab XID, this is the integrated development environment which is being used for various embedded applications. And second one is our MPLab XC compiler, which is used to convert a user writer program to machine level language. And third is the PICSimLab, which is the hardware simulator to demonstrate this project. And now we'll move to our design and development. So it is our PIC16F877A microcontroller architecture, in which we have various inputs and outputs. Some are the components are there which act as input and output both, like we have GPIO, 12C, matrix keypad, CLCD, RS232, etc. And we have some Components which act as the inputs like LM35, this is a temperature sensor, ADC, that is analog to digital converter, LEDs, LEDs are the outputs, and SSDs are also the outputs. So this is the overview of the PICGenius architecture. Now we'll move to talk about the PIC16F877A microcontroller. Uh, so it can operate up to frequency of 20 megahertz. Its operating voltage is 4.2 to 5.5 volt, and it does not have any internal oscillator. Its maximum current each port can source or sink is about 100 milliampere, and it is a 8-bit microcontroller which contains 40 pins. We'll continue about it, and it has a program memory of 14.3 KB. Its data bus is 8 bits, and the CPU speed is 5 million instructions per second. The RAM size is 368 bytes, EEPROM size is 256 bytes, and we have several other features like ADC, SSP with SPI and 12C, USART, and 3 other timers. Now we'll talk about one important component for which we'll use in this project, that is CLCD. It is a character liquid crystal display, and in the software which we are using, that is PICSimLab, it has two types of display, that is 16 cross 4 and 16 cross 2. And for this project we will be using 16 cross 4 display because we need at least 3 or 4 lines in order to display our various program modes. What is its function? It displays ASCII and some special characters. And there are two communication modes, that is 4-bit and 8-bit modes. Now we will move to tactile switches. So what is tactile switches? It is a switch whose operation is perceivable by touch, and this switch is used to select washing type, water level, start and stop, as well as open to. And the switch will produce a bouncing effect whenever it will be pressed. And we have one diagram which comprises of a microcontroller. At the left side we have pull-up register, and the right side we have pull-down register. So what is pull-up register? In this, the current will flow from VDD to ground. In order to avoid short circuit, we will add a resistor. So when the switch will be open, it will be pulled up. So that is known as pull-up resistor. And on the second side we have pull-down resistor. Here the current will flow from microcontroller to ground, and in order to avoid the short circuit we have connected a resistor here also. So when the switch will be open, it will be pulled down, and it is called as a pull down resistor. Now we're moving to interrupts. So what are interrupts? It is a communication process which is set up in a microprocessor or a microcontroller, in which an internal or external device requests a MPU or MCU in order to stop the processing. Then the MPU or MCU acknowledges the request and attends to the request. The control goes back to the process where it was interrupted. Polling. Polling, it is a process where the computer or controlling device waits for an external device in order to check the readiness or state, often with low-level hardware. Now we'll move to one another important part of our project, that is timer. So what is the role of timer? It's an very important application in any embedded system where it acts as a default peripheral which maintains the timing of an operation in sync with a system clock or an external clock. We have various components inside it, like we have tick, which is based on an instruction cycle, that is up count or down count. And resolution, it is the length of the timer register, which can be 8-bit or 16-bit. Quantum, it is the period of the tick. And scaling, it is a method where we can delay the process of going into ISR if required. So now now we will move to our implementation of the project. So this is our MPLab X integrated development environment for developing different embedded applications. Like I have done this washing machine simulation using this MPLab ID and PICSimLab. So this I have named this project as washing machine, which comprises of different files in which I have header files where I have defined different files like CLCD, H. Here I have defined all the macros which I am using in CLCD.c. This is the digital keypad where I have defined all the macros for digital keypad.c. This is the main.h, and this is our timers, and this is our washing machine header file for washing machine function.c file, where I have defined all the functions like power on screen, clear screen, washing program display. These are all the functions and macros which I am using in washing machine function. Now I will move to source files. So these are source files. This is the CLCD logic which I have used for displaying any program on the CLCD screen, and this is the digital keypad logic where I have used that long press logic for changing the screen to from one screen to another. And this is the ISR function. This is the main.c file where I have implemented this logic called press switch, and switch 5 for start, switch 6 for stop. All these logics are defined in the main.c. And then this is the timers. Number of ticks in PR is given 250, and this is the line where the timer interrupt is enabled. Now we'll move to washing machine function definition. This is the washing machine function definition file where I have defined all the 12 function modes and all the water level modes, and what are the different uh, screens we are displaying on CLCD. We have defined everything on in this washing machine function file. Now we'll build this project. So it has been built successful, and we have got one hex file, this one. So we'll copy this path in order to run this in PICSimLab. We'll move to PICSimLab. So here we will load that file which we have got from MPLab. We'll again copy it. It is already there. We'll paste the link, and this is the file which hex file which we have created. So now we can see this message: press key 5 to power on washing machine on CLCD screen. So we can see at the left side we have two screens, but we are using 16x4 because we are displaying a long message, so we can't use 16x2. And our clock frequency is 20 megahertz. and our microcontroller is PIC16F877. So now we'll perform like how this washing machine is working in real time. So it is saying that press key 5 to power on the washing machine. So we have 6 switches, that is RB0, RB1, RB2, RB3, RB4, RB5, and it is saying that press key 5. So key 5 is RB4. So I will press key 5 to power it on. It is getting powered on, and we can see the CLCD screen which is showing us the washing program. So here we have different washing program function modes. We have about 12. We can scroll it down using switch 4. So these are the 12 function modes, and we can see that there is a star in front of daily. So this indicates that we are selecting that daily function mode in order to perform the further operation. So we'll select this daily by using long press. We can select any one. I'm selecting daily. So we got this water level screen which comprises of auto, low, medium. If I scroll it down, then I will get high, max. So we have total 5 water level options. I am selecting max by using long press logic. So we have got this screen called press switch, where switch 5 is used for starting this operation and switch 6 is used to stop the operation. So I will press RB4, that is switch 5, in order to start the operation. So our program is daily and time is 40 seconds. So we can see that this fan is working. I mean, this washing operation is being performed. We can pause it also by using switch 6, and again we can start it using RB4. We can use this RB0 option, like switch 1 option, to show that if door is open, then we can close the door. And now we have 10 seconds to left. After that the function will be completed. So it is completed, and now it shows that a program is completed. Remove the cloths by uh, alarming it, showing that buzzer is giving alarm that it has been completed. So remove the cloths. So this is the whole project which I have done during this internship, and I have concluded that this project, it has effectively showcased that how embedded systems can automate various household appliances, and it also helped me to build practical skills in programming microcontrollers, interfacing sensors, controlling motors, and managing user interactions, creating a solid base for applying embedded technologies in real world scenarios. So, thank you all.